In this video, we're going to focus in on the structure of an atom and the different pieces that make it up. So we're going to make sure we can specify charge, mass, and location of our three major types of subatomic particles. So the things we're talking about here, those subatomic particles, right? Sub meaning inner, atomic atom, so things that are inside of the atom. And then we're talking about particles. So the three we have are protons, neutrons, and electrons. And as mentioned here, we need to make sure we understand charge, relative mass, and location. So protons. Protons are positive, so +1 charge. Neutrons are neutral, so they have a charge of 0. And electrons are negative, so -1. So P positive, N neutral, and then electrons, just what's left over being -1. Relative mass, what we really care about is how these compare to each other. So what matters in our head is protons have a relative mass of 1. Neutrons also have that same mass of 1. And then compared to that mass of 1 for protons and neutrons, electrons are so small that we say they have no mass. So in the textbook, it'll talk about what the actual true masses are for these particles. And while it's interesting to see how small that number is, this relative mass, the 1, 1, and 0, is what is useful and important for moving forward. Then for location, protons are inside the nucleus, as are the neutrons. And then the electrons are in orbitals outside of the nucleus. So those are our three particles, their charge, their relative mass, and where they are located. So let's put this into practice here with a practice question. So here we want to indicate which subatomic particle is being described by these phrases. And notice that more than one particle could be used to answer each question. So for the first one, we have possesses a negative charge. So the only particle we have that is negatively charged is the electron. Has no charge. That was the neutron, or neutral. Has a mass slightly less than that of a neutron. Now this is with respect to the true mass. So we can use a process of elimination here though without actually having to go back to those true masses. So we're talking about something that's slightly less than a neutron. So we said the neutron and protons were both approximately 1 compared to a full 0 of electron. So what this is talking about here is the proton. And again, if you go and look at those actual masses for neutrons and protons, you'll see the proton is just a little bit less than the neutron. But on the scale that we're talking about, it doesn't matter, so we consider them both to be 1. Then D has a charge equal to but opposite in sign from that of an electron. So electrons were -1, so the equal and opposite would be +1, which was the proton.